Hi guys, in today's video we're going to look at initial rate, clock reactions, orders and rate concentration graphs, the rate constant, and finally an exam style question.
Well, the initial rate is the rate at the start of the reaction when T is equal to 0. And we can actually vary the concentration of our reactant, recording the initial rate of reaction, and produce a rate concentration graph. These graphs have unique shapes, allowing us to determine the order of the reactant which we had changed. So how do we do this? Well, we repeat our experiment several times. Each time we vary the concentration of one reactant and only one reactant. We obtain an initial rate for each concentration and record this, and we'll then plot concentration against rate on a concentration rate graph, where concentration, which is being changed, is on the x-axis and rate is on the y-axis. And the unique shape of these concentration rate graphs will allow us to predict the order of the reactant. So let's have a quick look now at clock reactions. Well, some reactions produce visible changes. There may be a colour change or a precipitate may be formed, and the time taken for these changes to appear is measured. So we can actually use this relationship here. Rates directly proportional to 1 over t, where t is the time taken for a change to appear. And the way we can measure the time taken for changes to appear is with these clock reactions. We would place a piece of paper with an X on it underneath our reacting vessel. We then start our reaction, starting the timer, and as soon as the X becomes obscured, we stop the timer, giving us a measure of t, the time for the reaction to occur, and 1 over t will give us a measure of the initial rate. So, let's look at the orders and the graphs they produce. Well, for our zero order reaction, a change in concentration has no effect on rate. So you can see here in our concentration rate graph, as concentration is changed, the rate does not change. The line is flat. For our first order reactants, a change in concentration is directly proportional to a change in rate. So we see that rate is directly proportional to a change in our concentration of our reactant. Let's call it A. So we have a linear graph that's increasing.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, click the button. Join me today and together let's make A-level chemistry a walk in the park.